Computers speak in a language of ones and zeros, or bits. But what exactly are they, and how do you actually read them? We're here to tell you just that. My name's Aaron, and you're watching Tech at a Glance. If you think about the human English language, you can basically break it down into a combination of letters, numbers, and symbols. Put them together in a certain order, and your brain can interpret them into an understandable message. Computers interpret and save information as a series of switches, or bits. Think of them like light switches. They can either be on or off. In the computer sense, on is saved as a 1 and off is saved as a 0. This is often called binary notation. In modern computer architectures, data is usually grouped together into 8 bits, or 1 byte. When you have 4 megabytes of memory available, it means that your computer can actively store the states of 4 million bytes, or 32 million bits, or 32 million switches at a time. When your internet speed reads 10 megabits per second of download speeds, it means that you can actively receive about 10 million bits per second, or 1.25 million bytes per second into your computer from the internet. The interesting thing about binary notation is, despite the fact that it uses only switches, it can be easily converted into a human understandable language. Let's take numbers for example. Say you have a sequence of 8 bits, 11010101, and the computer considers this as a single 8-bit binary number. From here, all you really need to remember is your powers of 2. The bit on the furthest right is interpreted as 2 to the 0. The bit to the left of it is interpreted as 2 to the 1, then 2 to the 2, 2 to the 3, and so on and so forth. Now look at the value of each bit and multiply that by its corresponding base 2 number. Take everything and add them together and you get the represented number. Just remember that an 8-bit binary number can only represent numbers from 0 to 255. Anything bigger and you'll need more bits, i.e. you'll need more memory to store the number. If you think about it, our human readable number system works kind of in the same way. The difference being that instead of using a base 2 notation, it uses a base 10 notation. With base 2, each digit can either be 1 or 0. With base 10, each digit can be anything from 0 to 9. So say you have a sequence of base 10 numbers, 1, 2, 3, 4. We know this means 1234, but if you break it down, this is basically 1 times 10 to the power of 3, plus 2 times 10 to the power of 2, plus 3 times 10 to the power of 1, plus 4 times 10 to the power of 0. Groups of 8 bits or byte can also be used to interpret letters or symbols using a conversion method called ASCII. For example, an uppercase T would be represented by this, a lowercase e would be represented by this, a lowercase c would be represented by this, and a lowercase h would be represented by this. Hey, that spells tech. Full binary to ASCII conversion tables can be found online if you're interested in knowing the entire alphabet. Link below in the description. Okay, so we've been looking at bits at kind of a small scale in terms of converting them into numbers or letters. But oftentimes they're used for many more types of data than just that. Digital music, like from your iPod or computer, is stored as millions of bytes or megabytes, representing the audio signal from the song they correspond to. Video games use billions of bytes or gigabytes to represent everything from textures and character models to sound effects and voiceovers. Even this video right now is being transferred into your computer at kilobits per second and interpreted as video and audio data to be played back on this YouTube video player. If you like topics like these, please be sure to like the video below and comment as well. Leave a comment to tell us what other topics you would like us to cover at Tech at a Glance. And don't forget to subscribe. Our next video is basically a follow-up to this one. We'll explain why your 500GB hard drive won't actually show up as 500GB on your computer. Maybe it's a conspiracy? You'll just have to find out next time.